Imagine a world where the line between sky and road no longer exists, where vehicles no longer obey the limits of asphalt and traffic. In 2026, Maxwell Chikumbutso made this world real. Not as a prototype, not as a concept, but as 20 fully functional flying cars capable of operating safely, efficiently, and at speeds previously reserved for aircraft. These are not ordinary EVs with wings attached. Each vehicle is an integrated marvel of engineering, combining electric propulsion, AI-assisted flight control, modular aerodynamic design, and autonomous navigation systems that adapt to both urban environments and open skies. As these vehicles prepare for their first public launches, the global automotive and aerospace industries are watching in disbelief. A single innovator in Africa has challenged decades of assumptions about what's possible, proving that vertical mobility is not just the future, it is now. Step inside the story of these 20 flying cars. From their design labs and prototype tests to the first fully coordinated launch over cityscapes, rivers, and highways, we'll explore how Maxwell Chikumbutso's vision turned aviation dreams into operational reality. Number 20. Compact Urban Flyers. Designed for tight city environments, these vehicles can take off vertically from parking garages, hover above traffic jams, and land safely on rooftops or designated urban paths. Their AI systems scan obstacles in real time, adjusting thrust and trajectory to avoid collisions and maintain stability, even in turbulent conditions. Number 19. Long-range commuters. These are the flying cars built for distance. Equipped with advanced battery packs, lightweight carbon fiber chassis, and energy-efficient propulsion systems, they can cover hundreds of kilometers on a single charge. For commuters, this isn't just speed, it's freedom from traffic, infrastructure limitations, and urban congestion. Number 18. Modular cargo flyers. Beyond personal transport, Maxwell's team engineered flying vehicles capable of carrying modular cargo units. From medical supplies to critical deliveries, these cars redefine logistics by bypassing conventional ground bottlenecks. AI-managed flight corridors ensure efficiency and safety, allowing entire fleets to operate simultaneously over urban and rural landscapes. Number 17. Autonomous safety platforms. Each flying car is embedded with advanced collision avoidance, predictive weather adaptation, and emergency landing protocols. In essence, they are self-aware vehicles capable of responding faster than human reflexes, drastically reducing risk while increasing operational confidence. Number 16. Energy regenerative flyers. Some vehicles feature regenerative thrust technology, harnessing energy during descent and braking maneuvers to recharge batteries mid-flight. This extends operational range and introduces efficiency mechanisms previously unseen in personal aviation. Number 15. Amphibious flying cars. Maxwell's engineers even experimented with vehicles capable of transitioning seamlessly between air and water. Hovering over rivers, lakes, and coastal regions, these hybrid designs expand mobility into previously unreachable areas, integrating air, road, and water travel into one coherent system. Number 14. High-speed intercity flyers. For longer distances, vehicles are engineered to reach velocities that rival small aircraft, with AI navigation optimizing air corridors to prevent congestion and maintain efficiency. These are the ultimate express vehicles, reducing hours of travel into minutes without sacrificing safety. Number 13. AI pilot assist vehicles. Some models focus on enhancing human piloting rather than replacing it, offering co-pilot AI that predicts wind currents, traffic, and optimal flight paths while allowing manual override. This ensures a seamless learning curve for early adopters while maintaining maximum safety. Number 12. Emergency response flyers. Specialized designs for first responders, ambulances, and disaster relief allow rapid deployment over congested or disaster-affected areas. These vehicles integrate medical payloads, life support systems, and AI routing algorithms capable of finding the fastest paths under extreme conditions. Number 11. Compact foldable flyers. Innovations in wing folding mechanics and retractable rotor systems allow certain models to collapse into compact forms, making urban storage, parking, and street-level navigation possible while preserving full flight capabilities. Number 10. Luxury sky cruisers. These high-end models combine premium interiors, panoramic glass canopies, and AI-driven personalized flight experiences. They merge comfort with high-performance flight, making aerial mobility not just functional, but aspirational. Number 9. Experimental VTOL flyers. Vertical takeoff and landing technology has reached unprecedented refinement. Maxwell's experimental VTOL vehicles operate with near-silent thrust systems, precision landing capabilities, and advanced stabilization, showcasing the future of urban air mobility. Number 8. Modular multi-vehicle integration. Some models are capable of coordinating with other flying vehicles autonomously, forming fleet formations for efficiency, energy savings, and collective traffic management. This introduces a new dimension to aerial traffic optimization. Number 7. Adaptive weather flyers. Equipped with atmospheric sensors and AI-assisted adaptive flight controls, these vehicles can detect microclimate changes mid-flight and adjust lift, speed, and angle of attack for maximum stability, even in challenging weather. Number 6. Biometric security flyers. Every vehicle integrates biometric authentication, ensuring only authorized users can operate them. Coupled with encrypted AI communication channels, this ensures both safety and privacy in a rapidly expanding airspace. Number 5. Autonomous delivery flyers. These specialized units revolutionize urban logistics, autonomously transporting high-value cargo, perishable goods, and emergency supplies across cities and regions with speed and precision unmatched by ground vehicles. Number 4. Interoperable mobility flyers. Maxwell's vehicles are designed to interface with existing transportation infrastructure, smart cities, and other autonomous vehicles. They communicate in real time to optimize routes, avoid congestion, and coordinate with public transit systems. Number 3. Scalable fleet flyers. Entire fleets of these vehicles can be deployed simultaneously, with AI monitoring every unit to maintain safety, spacing, and efficiency. This demonstrates that aerial mobility is not just personal, it's scalable. Number 2. Urban to regional flyers. Bridging the gap between city streets and regional travel corridors, these vehicles provide seamless transport across metropolitan, suburban, and rural zones. They reduce travel time, energy consumption, and infrastructure stress. And finally, number 1. The flagship flyer. This is Maxwell Chikumbutso's crown jewel, a vehicle that embodies every advancement achieved across the fleet. AI-assisted autopilot, modular energy regeneration, VTOL precision, interconnectivity with other vehicles, luxury interiors, and extreme range. It is the ultimate demonstration of what personal aerial mobility can be in 2026. And this fleet of 20 vehicles is not just about transportation. It represents a paradigm shift. A vision where roads are optional, cities are three-dimensional, and mobility is no longer constrained by terrain or traffic. But this is only the beginning. And the implications go far beyond personal mobility. These 20 flying cars signal a seismic shift in how society could move, work, and interact. Imagine emergency services responding in minutes instead of hours, disaster relief supplies reaching inaccessible regions instantly, and logistics networks operating in 3 dimensions rather than being constrained by roads. The ripple effects are enormous. Urban planning will evolve to accommodate aerial traffic corridors. Airspace management becomes a daily operational necessity. Cities will need dedicated takeoff and landing zones integrated seamlessly into residential and commercial areas. The vehicles themselves will continue learning, AI constantly refining flight paths, energy efficiency, and safety protocols based on collective fleet data. Maxwell Chikumbutso's vision doesn't stop at individual flying cars. Entire networks of autonomous aerial vehicles could operate in unison, creating smart skies where traffic flows are optimized, energy usage is minimized, and collision risks are nearly eliminated. This is a future where congestion is virtually erased and transportation becomes an adaptive, living system. Even more remarkable is the accessibility potential. While luxury models demonstrate performance and design, compact and efficient urban flyers show that everyday commuters could soon have access to aerial mobility. The democratization of flight is now within reach, a reality that, until recently, seemed decades away. And as regulators, cities, and innovators begin to adapt, a new ecosystem emerges. Charging infrastructure will need to scale for electric flight. Maintenance hubs will specialize in airborne EV systems. Air traffic coordination AI platforms will merge seamlessly with ground-based transport management systems. Entire industries are about to pivot. Yet the most profound impact may be cultural. Humans have long dreamed of flight, but flight for everyone, not just pilots or corporations, changes how people perceive distance, opportunity, and connection. Regions previously isolated by geography are now accessible in minutes. Commerce, education, and healthcare can transcend terrain barriers. And as the fleet expands, Maxwell Chikumbutso isn't just launching vehicles, he's launching a paradigm. A paradigm where mobility is adaptive, integrated, and limitless. Where cities, suburbs, and rural areas exist in a dynamic three-dimensional ecosystem. Where innovation doesn't just respond to problems, it preempts them. But this is only the opening chapter. Because as AI, energy regeneration, VTOL systems, and fleet coordination continue to improve, the next generation of flying vehicles will not merely supplement ground transport, they will redefine infrastructure itself. Roads, highways, and traditional traffic planning will become secondary considerations. Entire urban landscapes could evolve to prioritize vertical movement, reshaping architecture, commerce, and lifestyle in ways we are only beginning to imagine. And the revolution doesn't stop with the vehicles themselves. It extends to the very way we think about logistics, energy, and connectivity. Imagine fleets of these flying cars forming integrated aerial networks, communicating with each other in real time to optimize traffic flow, energy consumption, and emergency response. Each vehicle becomes a node in a larger intelligent system, learning from every journey and sharing data across the fleet to improve efficiency and safety for all. This is where personal mobility intersects with urban intelligence. Airports, heliports, and even rooftops transform into dynamic hubs, seamlessly linking aerial and ground transport. Cities become three-dimensional ecosystems, where the concept of rush hour may eventually disappear, replaced by fluid aerial corridors governed by AI. The implications for commerce are equally staggering. Supply chains no longer need to rely solely on roads or rail. Goods can be transported directly from production sites to urban centers, bypassing traditional bottlenecks. Medical supplies, perishable goods, and emergency aid can reach remote or disaster-affected areas faster than ever. Maxwell Chikumbutso's fleet isn't just about luxury or convenience. It's about redefining the velocity of human activity itself. And while these flying cars are revolutionary in technology, they are also revolutionary in accessibility. By developing models that cater to different ranges, capacities, and use cases, from urban commuters to emergency response units, Maxwell is creating a scalable ecosystem. This means the potential for everyday people to participate in aerial mobility is closer than anyone imagined, while industrial, governmental, and humanitarian applications scale simultaneously. Energy infrastructure evolves alongside mobility. Each vehicle's regenerative systems feed back into smart grids, ensuring that the energy used for flight is optimized and recycled wherever possible. Solar-assisted charging stations, distributed microgrids, and AI-managed power allocation form the backbone of this aerial network, making flight sustainable, reliable, and scalable. Education and workforce development also play a role. Pilots, engineers, AI specialists, and urban planners must adapt to a three-dimensional transportation world. Maxwell Chikumbutso's innovation is inspiring a new generation to not just consume technology, but to create, maintain, and expand it. The ecosystem isn't limited to vehicles. It's a complete reimagining of society's relationship with mobility, energy, and urban design. And the most exciting part? This is just the beginning. As AI flight management systems, autonomous piloting, and energy efficiency improve, the fleet will expand, operations will scale, and the possibilities will multiply. Maxwell Chikumbutso's 20 working flying cars are not just a glimpse of the future. They are the foundation for a world where the sky is no longer a boundary, but a frontier waiting to be explored. And as the sky fills with these flying vehicles, the broader impact begins to ripple across society in ways we are only starting to grasp. Urban landscapes will be reimagined. Skyscrapers, rooftop gardens, and vertical transport hubs become not just architectural statements, but functional nodes in a three-dimensional transit system. Parking lots shrink, roads are repurposed, and cities evolve from horizontal sprawl to layered vertical ecosystems. Beyond urban planning, commerce itself transforms. Retail, logistics, and service industries adapt to aerial delivery and rapid transport. Small businesses gain access to markets previously unreachable, and emergency services can respond faster and more efficiently than ever before. Human connection, visiting family, attending meetings, or accessing education, transcends geographic constraints. Entire regions that were once isolated now participate in the economy with unprecedented agility. Global industries are watching closely. Aerospace and automotive giants are reassessing decades of research, acknowledging that the integration of AI, VTOL technology, and energy-efficient propulsion may redefine not just personal mobility, but the fundamentals of transportation infrastructure worldwide. Maxwell Chikumbutso's fleet is proving that disruptive innovation doesn't always come from established hubs. Sometimes it comes from vision, courage, and relentless execution. But perhaps the most transformative element is the data. Every flight generates information: aerodynamic performance, energy usage, traffic patterns, weather conditions, which feeds into AI systems, continuously refining flight control, safety protocols, and operational efficiency. The more the fleet flies, the smarter it becomes. Each vehicle learns from the others, creating a collective intelligence capable of anticipating challenges, avoiding collisions, and optimizing airspace in real time. The societal implications are equally profound. Education adapts to prepare the next generation of engineers, AI specialists, and urban planners. Workforce development aligns with this new reality, ensuring that people are equipped not just to use flying cars, but to design, maintain, and expand the ecosystem. New jobs, new industries, and new standards of living emerge, all propelled by the convergence of technology, vision, and ambition. And while the technology itself is breathtaking, its cultural significance cannot be understated. Humanity's dream of flight, long constrained by regulations, infrastructure, and cost, has become tangible, accessible, and scalable. Flying is no longer fantasy. It is a practical extension of daily life. Maxwell Chikumbutso has done more than launch 20 vehicles. He has opened a door to a new paradigm where mobility, energy, and intelligence converge to redefine what's possible. Yet, even as these flying cars take off and ecosystems begin to form, one question remains. How will societies adapt to living in a world where the sky is no longer a limit, but a thoroughfare? The answer to that question will unfold gradually as governments, urban planners, and citizens adapt to a three-dimensional mobility reality. Air traffic regulations will need to evolve in real time, balancing safety, efficiency, and accessibility. Cities will begin designating vertical lanes, dynamic flight corridors, and rooftop landing zones, integrating these into existing infrastructure without causing disruption. Meanwhile, the social impact will be profound. Communities that were once isolated by rivers, mountains, or poor road networks will now experience unprecedented connectivity. Schools, hospitals, and businesses in remote areas will have access to resources and markets that were previously out of reach. Human productivity, collaboration, and opportunity will expand, reshaping economic landscapes both regionally and globally. Maxwell Chikumbutso's flying cars are not just vehicles. They are catalysts for an entirely new mobility ecosystem. Every launch, every test flight, every optimization pushes boundaries, setting standards for safety, efficiency, and design that others will soon follow. Other innovators around the world are studying these vehicles, adapting lessons learned, and accelerating the global shift toward urban air mobility. The environmental implications are equally significant. Electric propulsion and regenerative energy systems mean that flight can be both clean and efficient. Airborne transport reduces congestion on roads, lowering emissions from traditional vehicles. When scaled across entire fleets and cities, These innovations could redefine sustainable mobility on a continental level. And as fleets grow, so does the intelligence embedded in them. Swarm algorithms allow vehicles to coordinate autonomously, optimizing routes to save time, energy, and reduce risk. Predictive AI analyzes weather patterns, traffic density, and energy consumption in real time, ensuring that the entire aerial network operates like a living organism. Culturally, the presence of flying vehicles will redefine perception of space, distance, and freedom. Human ambition is expanding vertically. Families can travel across cities in minutes. Emergency responders can access disaster zones faster. Entrepreneurs can deploy products across regions instantaneously. Yet, even with all this technology, the core of Maxwell Chikumbutso's vision is human-centered. Every vehicle is designed not just to fly, but to improve lives, solve problems, and empower communities. Mobility is no longer just about speed or luxury. It's about possibility. And this is only the first wave. Today, we see 20 working flying cars. Tomorrow, entire fleets will populate urban skies. Autonomous delivery, medical evacuation, public transit, and personal transport will converge into a fully integrated aerial ecosystem. The sky is no longer the limit. It's the beginning. The question now is not if flying cars will change our world, but how fast and how profoundly they will reshape every aspect of human life. And as these 20 flying cars continue to take off, landing, and redefine what's possible, one truth becomes undeniable. Maxwell Chikumbutso has not just built vehicles, he has ignited a new era of human mobility. The roads we once relied on are no longer the only paths forward. Cities, communities, and industries are being reshaped by air, by intelligence, and by ambition. This is more than innovation. It's a transformation of society, of opportunity, and of perspective. The dream of flight that has inspired humanity for centuries is no longer confined to imagination. It is here. It is real. And it is accessible. Maxwell Chikumbutso's 2026 fleet of flying cars marks the beginning of a future where mobility knows no limits, where technology empowers every dimension of life, and where the sky is no longer a ceiling. It's a launching pad for endless possibility.